All right, what's up, y'all? I'm just kidding. Okay, so unit circle. Remember when I was like, y'all have to memorize the unit circle? I don't know when I'm not from Texas. I don't know why I'm saying y'all. But yeah, so you need to memorize the unit circle, or at least have a copy of the unit circle somewhere so that you can reference it. Okay. Remember, you can memorize the entire unit circle just by knowing this first quadrant right here. Remember, because like this point reflects, and same here, like they're all the same points, but just the signs are different. Okay? So yeah, Mr. Willy Wonka is like, come on guys, memorize that unit circle. And remember that sine is your y value. Cosine is your x value, and tangent is y over x. Remember that. Write it down right now. Pause the video, write it down. Okay? So here's these. Now these you do not have to memorize. Write them down, print them out, whatever you need to do, but just have them somewhere that you can reference them, but you don't have to memorize them. Okay? Like the ones that we did in the last video, yes, absolutely memorize them. Okay? These ones, just have them somewhere that you can reference. Okay? And we need to find the exact value of each trig expression. So let's look at the first thing I'm going to do, and I'm going to write all the angle measures on the unit circle. Okay, because we know like what the sine of 30 is. We know what the sine of 150. We can find the tangent of 225. We can find the cosine of 270 just from looking at the unit circle. Well, now we're doing some that are not, I mean, they're technically on the unit circle, but there's not an exact point that's pointing to them. And we want to know the exact value, so we can't just plug this into our calculator because calculators give us decimals. Decimals aren't exact, like a square root is more exact than a decimal, okay? So sine of 105. We need to find two measures here that add up to be 105. And there's probably a couple different ones you could do, like, or you could do subtraction, like you could do 135 minus 30. That's going to give you 105, and you'll get the same thing. I end up doing 45 plus 60. Okay, and it doesn't matter. It literally doesn't matter. Like, if you wanted to do a different one, you can. If you want to do 150 minus 45, totally fine. Okay, I like to stick with addition. If I can find two that add, then I do that. So 45 plus 60. So sine of 105 is the same as sine of 45 plus 60. Well, now, if we're using the formulas that I said that you need to have to reference, that one right there is sine of A plus sine of B sine of A plus B is the same as sine of A cosine of B plus cosine of A sine of B. And it doesn't matter which one is which one is A and B, just as long as like you stick with it. So I just always say like my first one's A, my second one's B. Okay? And I could have wrote this as whoops. I could have wrote this as sine of 60 plus 45, and that would just switch this to be my A and this to be my B. Okay, doesn't matter. So here we have sine of 45 times cosine of 60 plus cosine of 45 times sine of 60. Well, then if we look at the unit circle, at 45 degrees, the y value there is square root of 2 over 2. At 60 degrees, the x value there is 1/2. At 45 degrees, the x value there is square root of 2 over 2. And at 60 degrees, the y value is square root of 3 over 2. And then if we multiply this, we get square root of 2 over 4, because 2 times 2 is 4, plus square root of 6 over 4. Have a common denominator. Just think back to like, I don't know, 5th grade, whenever you learn fractions. If you had 1/3 plus, actually I don't want to do thirds. If you had 1/9 plus 4/9, that equals 5/9. You are all 100% capable of doing that. I know you are. You are 100% capable of doing this. It's the same exact thing. So then that means that we can write this as one fraction as square root of 2 plus square root of 6 over 4. So that's what the sine of 105 equals. Cool? Let's do cosine of 165. So again, we have to find two measures on the unit circle that add up to 165. I chose 30 and 135. You could have done, let's see, 120 and 45. That would have gave you 165. You could have done, I don't know. I'm sure there's other ones you could have done. But here we're doing cosine of 30 plus 135. Okay, so now we're using this one right here. And remember, you can use subtraction too. You would just be using these ones. So that's cosine of A times cosine of B minus sine of A, sine of B. Where in this case, our A is 30 and our B is 135. So this is going to be cosine of 30 times cosine of 135 minus sine of 30 times sine of 135. So then cosine of 30, so the x value at 30 degrees is square root of 3 over 2. The x value at 135 is negative square root of 2 over 2. The y value at 30 is 1/2, and the y value at 135 is square root of 2 over 2. So if we multiply that, we get negative square root of 6 over 4 minus the square root of 2 over 4. Make this one fraction. That's the same as negative square root of 6 minus square root of 2 over 4. So the cosine of 165 equals negative square root of 6 minus square root of 2 over 4. Okay. Now this one, whenever it's in radians, I convert it to degrees. And that's what I think you should do also. So 12 pi over 9, remember to convert to degrees, we just multiply by 180 over pi. So 19 pi over 12, I don't think that's what I said when I said that, sorry. 180 over pi. These cancel. 12 goes into 180 some number of times. I forgot. But yeah, and then you end up with 285. Okay. So here, 285, let's use 60 and 225. You could have used 240 and 45. You could, whatever you come up with is fine. So that means that cosine of 225 plus 60. So we're using the same one we used last time. So that's going to be cosine of 225 times cosine of 60 minus sine of 225 times sine of 60. Well, the x value at 225 is negative square root of 2 over 2. The x value at 60 is 1/2. The y value at 225 is negative square root of 2 over 2. And the y value at 60 is square root of 3 over 2. So then we end up getting negative square root of 2 over 4. And then a negative minus a negative is a positive, so plus square root of 6 over 4. Same denominator, so this becomes negative square root of 2 plus square root of 6 over 4. So that means the cosine of 19 pi 12ths is negative square root of 2 plus square root of 6 over 4. Okay, same exact thing here. Let's make this into degrees. So multiply it by 180 over pi. So that's sine of negative 75, which 120 and 45 will give us 75. We just have to do 45 minus 120. So if we do 45 minus 120, that gives us that negative 75. And I think there's definitely other ones you could have done. I just chose this one. Okay, so then we're using this equation right here. So that's going to be sine of 45 times cosine of 120 minus cosine of 45 times sine of 120. Okay, and that's not a negative 120. It's just positive 120. Okay, this difference, since we're using the difference, it takes into account this subtraction or the negative there. Okay. So the y value at 45 is square root of 2 over 2. The x value at 120 is negative 1/2. The y value at, or the x value at 45 is square root of 2 over 2. And the y value at 120 is square root of 3 over 2. So this is negative square root of 2 over 4 minus square root of 6 over 4, which is negative square root of 2 minus the square root of 6 over 4. Cool. Okay, this one, so tangent gets a little ugly, but we can do it. So tangent of 13 pi over 12, let's change that to degrees. So that's tangent of 195, which let's use 45 and 150. Okay, there's other ones you could have definitely used here, but that's what we chose. So we have tangent of 150 plus 45. So we're going to use the sum here. So this is going to be tangent of 150 plus tangent of 45 over 1 minus tangent of 150 times tangent of 45. Well, let's find the tangent of 150 and tangent of 45. So if we look at, I'm going to go back for a second. So if we look at 150, 150 is right here. So that point is negative square root of 3 over 2 and 1/2. And remember, tangent is y over x. So the y value here is 1/2. The x value here is negative square root of 3 over 2. When you have fractions like this on top of each other and one of the fraction, or they both have the same denominator, you can just cancel those denominators. And we are left with negative 1 over the square root of 3. So the tangent of 150 is negative 1 over the square root of 3. Okay, and then for 45, we're looking at this. That's square root of 2 over 2, square root of 2 over 2. If we do y over x, that's square root of 2 over 2 over square root of 2 over 2, which just equals 1. Okay, so the tangent of 45 equals 1. Okay, and I'm not going to make you rationalize that. So tangent of 150 is negative 1 over square root of 3 plus 1 plus the tangent of 45, which is 1. Then 1 minus the tangent of 150, so negative 1 over the square root of 3, and then times 1. So that means we have negative 1 over the square root of 3 plus 1 in the numerator. And we have 1 plus 1 over the square root of 3, because a 2 double negative makes a positive. Let's get this so that they have common denominators on top and bottom. So I can just change those 1s to square root of 3 over 3. Square root of 3 over square root of 3. So on top, I'm left with negative 1 plus the square root of 3 over the square root of 3. On bottom, I have square root of 3 plus 1 over the square root of 3. Those square root of 3's cancel. The same thing that we did over here. And I'll show you, let's just show you real quick why they do. So say that you had like 3/2 divided by 5/2. Well, we could change that to division. So 3/2 divided by 5/2. Flip and multiply. So you have 3/2 times 2/5. Well, now those 2's cancel, so you're left with 3 over 5. So you could just cancel the 2's outright in the beginning, which is why we were able to just like say goodbye to those. Okay, and I'm not going to make you rationalize this. We're just going to leave it just like that. Okay. This one, so let's change it to degrees. So that's negative 105, which let's use 35 or 135 and 30. If we just do 30 minus 135, that will give us negative 105. So that's going to be tangent of 30 minus tangent of 135. Then 1 plus tangent of 30 times tangent of 135. Well, again, all right, let's find the tangent of 30. So 30 is right here. That point is square root of 3 over 2 and 1/2. So y over x, that's 1/2 over the square root of 3 over 2. 2's cancel, so we have 1 over the square root of 3. Okay, 135 is here. So we have negative square root of 2 over 2, square root of 2 over 2. Since those are the same, if we divide them, if we have square root of 2 over 2 over negative square root of 2 over 2, we're just left with negative 1. Okay, so that means tangent of 30 is 1 over the square root of 3 minus negative 1, and then 1 plus 1 over the square root of 3 times negative 1. So a double negative becomes a plus. And then we have, when you multiply the 1 over the square root of 3 times the negative 1, it becomes negative, so that's just a minus. Same thing we did in the last one. Let's get a common denominator. So that's going to be 1 plus the square root of 3 over the square root of 3. And then square root of 3 minus 1 over the square root of 3. Those 3's cancel, and you get 1 plus the square root of 3 over square root of 3 minus 1. Okay. So these ones... Now we're given like the sum of angles here. let's condense this into a single function and then find the exact value. So this corresponds exactly to this. But in this case, our a is 48, our b is 102. So this is the same as tangent of 48 plus 102. Well, 48 plus 102 is 150, which is on the unit circle. So it's right here. That's negative square root of 3 over 2 and 1 over 2. Y over x, so 1/2 over square root of 3 over 2. The 2's cancel, and I'm just left with negative 1 over the square root of 3. Okay. This one, so cosine 300 times cosine of 15 minus sine of 300 times sine of 15. Well, that's the sum of angles. That's this right here. So that means a equals 300, b equals 15. So this is going to be cosine of 300 plus 15, which is cosine of 315, which if you find 315 on your circle, the x value there is square root of 2 over 2. Okay. This one, so this is all in radians. I'm going to convert it to degrees. So we have tangent of 50 minus tangent of 5. 1 plus tangent of 50 times tangent of 5. And it looks like this is the difference of angles with tangent. So here this is going to be tangent of 50 minus 5, which is tangent of 45. Then if we look at 45 right here, that's square root of 2 over 2 over square root of 2 over 2, which equals 1. Okay. Again, convert this to degrees. So that's sine of 234, cosine of 24, cosine of 234, sine of 24. So that looks like the difference of angles, but with sine. So here, this is going to be sine of 234 minus sine of 24, which is sine of 210. So if you find sine of 210, it's the y value at 210, that's negative 1/2. Okay, these ones, same thing, but now we just have variables. We're not going to actually use our unit circle. So cosine 2x times cosine 4x plus sine 2x times sine 4x. That's this right here. So that's going to be cosine of 2x minus 4x, which is cosine of negative 2x. I should have put this in parentheses right there. Okay. Tangent of 4 theta plus tangent of theta over 1 minus tangent of 4 theta times tangent of theta. So that's tangent of a plus b. Well, that's tangent of 4 theta plus theta, which is tangent of 5 theta. This one, sine of pi halves times cosine of alpha minus cosine of pi halves times sine of alpha. That's going to be sine of pi halves minus alpha, because we're using this. And then we're just going to leave it like that. There's not a lot we can do with that one. This one, tangent of y minus tangent of pi halves. 1 plus tangent of y times tangent of pi halves. That's tangent of a minus b. So this is going to be tangent of y minus pi halves. Cool. There's an adorable monkey. I love monkeys. I miss my monkey posters. But yeah. That's it for this one. So unit circle, you need the unit circle. I would try your very hardest to memorize it. If you can't, at least be able to reference one. And yeah, hope you're doing all right.